So I guess what we're going to do first is I continue a little bit introduction on Python, and then afterward we'll start talking about like some simple stuff like just about color in images. And then I will go back with a little bit more OpenCV, I guess. So that's the plan. And let's continue with the Python. So last time, okay, this is I just opened from last time, right? So stuff. Let me just continue somewhere at the end, I guess. Wow, that's yeah. Let's move to the very end. Oh, okay, I have some. Maybe I just erase some of the stuffs here. This some daytime object. I guess I will just erase this one also. So okay, let's start from here. So make it even full screen. So next thing maybe like we look at some simple loop and then like conditions, and I mean it's I guess like last time we mentioned some of this more special syntax. And if you have any trouble, like always go back and Google, and there's so many documentation online. It's very easy to kind of like search, right? If you have anything unclear, like what you want to do. Basically, like anything you can imagine, like more or less can be done like on Python. And for simple stuff, like for example, last time someone asked like how to reverse a list and so on. Most likely you cannot, you do not need to write code from scratch to do that. Like probably already have some command to do that. And let's look at some I/O first. So for example, like I have this notebook is actually called Untitled one.i. Yes. So and let's just pin out the file here. This one is untitled one, I guess. Untitled one.ipynb actually. If you're going to write the file, you will have like something like that. If not, you can just ignore that. Like, so meaning that you only open it as read. Then I need to open this as some object, and then I can just maybe read that, maybe pin out the content of stuff. So the with open syntax here is kind of standard now. So I guess I is encouraged to do something like this, because you don't need to close the file. For example, if you're used to I don't know, any other like maybe Matlab, Matlab, Java, C, like when you open, you're supposed to close the file as well. So, and when you use with open here, everything like about the IO is inside the block here. So when you get outside the block, it's already closed. It's automatically closed. So then, oh, okay, it cannot find the file. Maybe, yeah, this is like type sensitive because I'm using Linux. So then open, so you just see like read the entire file here. And then like, so basically read as a string. So, and then of course you can do lots of stuff like whatever. There's some other command, I guess it has read line, something like that maybe. But yeah, you can search for that. Yeah, I guess I'm just say so much for the IO. And or like with the open. But one thing I like to talk a little bit more like about the IO is the pickle command. I shouldn't say pickle command, but the pickle. So basically, it's like if allow you to save any kind of object. So in serialize an object, so will be can be an image or a dictionary and so on, and then you can save it. So let me give an example. Like I need to. Oh, by the way, like whenever you import some packages, if you have a kind of a fresh installation, there's some echo. Let me make sure. Like let me turn off the mic of my other computer. Okay. So if you have any basically packages, like if you have a fresh installation, there's a chance that like yeah, there's some packages was not installed. Always just pick install that. And if you don't know what's the package, just Google that. Like, and Google the error message. There's a high chance that if anything doesn't work, it's just you didn't install the package. So corresponding packages. So just look for the error message, and usually just mm, you will solve that problem like right away. So let's see. I have Pickle. Let's say I have something like Hello World here. As some kind of like a dictionary. So by the way, I don't know. This is extremely silly. Oh no, okay. I'm not going to ask this. I want to ask. What's a hello? um, but yeah, let's forget it. I guess maybe I will reserve to a little bit more challenging questions maybe. So so I have this object here, say a hello, then I can save it as a pickle. So I open like maybe a file name for that is a pickle, and I need to save it. So I need to make it the file writable and also like it's binary, and as some pointer like here, I can call it fpt here. Then I will have pickle dump into this object into the file. So this will save into a pickle file. So now then I should have a file dummy.pickle in my folder. Maybe I can look at the size as well. It's 31 byte, I guess. And I can load this back. Maybe I save it into a new variable. Then I have B is the dictionary. So so B and A, by the way, like well, okay, maybe I do something like that. I set a just test some new things like new test. So I have a now it's a dictionary with both a index hello, a key with keys both hello and like test here. What do you think about B? Like does B contain test as well? Honestly, I don't know actually. I think it shouldn't, yeah. But be careful, like yeah. So but that's kind of the stuff that you want to always test around when you are new to this kind of languages, because then you yeah, this is a question now, like because everyone is answering that, like so yeah, it doesn't. Yeah. So be very careful. But on the other hand, if I have C equal to A and I have C, let's say A, I make another, and test is equal to another test. And now I have C is actually like, C is really pointing to the same object as A. So therefore, like I changing A, like C will be changed as well. So yes. So that's about Pickle that I like to talk about. Now if you play with MATLAB as well, like you know the map file, right? So I may have like variables that I have a matrix. maybe I have matrices I want to store into map file that I can open it back in MATLAB. So one possibility is that I also have a savemat command in Python that you will need the SciPy. By the way, most likely you don't have SciPy installed, right? So then you will probably need to pit install SciPy. Let's say I import like savemat and like loadmat here. Let's see. Yeah, I have that installed. So if you are playing with that at the same time and you have one into error message, then most likely you need to pit install the thing. Pit install SciPy. Yeah. And I'm not saying I just make a one, make a list here. It's like from 0 to 10. So X is like 0, sorry, 0 to 9. And then maybe I have a dictionary that is just storing like X is equal to X, let's say. So my dictionary therefore is just, yeah, with X is like with a list from 0 to 9. So now I store that as a MATLAB file, mat file. So I save mat dummy.mat and dict. So now I should have a file dummy.mat here. So you can see I have, this is a 264 byte. Let's see, what's the folder here, by the way? It's CV code. I don't have MATLAB installed here, but I have Octave. For you guys who don't know, Octave is a kind of open source clone of like MATLAB. Yeah, usually I don't use MATLAB that much now. I just install Octave because I don't need to worry about the license. It's like easier. So I have Octave. I can just check whether it's actually working. Let's say I just load this dummy. Well, I don't use MATLAB for a while. I don't remember even command how to see variable whose way. Yeah, so I have this X now is a 0 to 9, so as I expected. Of course, I can also like, for example, like if I create a new variable, say in MATLAB, in the same time can load it back into Python. Maybe I have Y is a matrix, like a random matrix of like 5, and save Y. Let's see, dummy 2 maybe. I think the command is not right. Dummy 2Y maybe. So I should have dummy 2 now, eh? Oh, sorry. I don't know why it's an error. So anyway, I think I should have dummy 2 now. Let's see it in Jupyter. Oh, it didn't save. So I guess the command is not correct. I don't know how to save. Oh, maybe I need to add .mat here. Let's see. Okay, let's see here. Oh, okay, now it's here. So yeah, I can load it from Python, right? And by the way, what's Y? Let's look at what's Y first. Y is like this random matrix here, like 5 by 5 random matrix. And to load the file, I can just use loadmat here instead. So I have loadmat dummy2.mat, and so load it to a new dictionary. Let's call it like mdic2 here. Oops, some problem here. Unknown map file type. Oh, okay, probably it's like some interoperability problem, like with Octave and maybe the version of the. Yeah, I won't bother with that then. Let me just say load back this dummy like uh uh let's see for maybe I just try one thing. So if it doesn't work, then I'll just give it up. I think it's a with the version problem. Let us say for out uh there's different version for the map file. As you can see, there's a mentioned version 7, version 6. Let's see, that's version 4. Let's try version 4. Maybe the earlier version it will works. So if it doesn't work, I'll just give it up, like because it's not something major. And you can figure that out as well. So let's try that. Yeah, that works. So you try to just say pick install. Okay, see if you just okay, someone raised a question and say cannot pick install like scipy like Python in Anaconda. How about if you just pick install like scipy? Yeah, I'm not sure the package name. So stuff like that you probably need to just Google honestly. Because Anaconda may have a different package name from Pick, like the manager. So and you can also contact install basically. Actually, that's the package manager recommended by Conda, but I asked you guys to use pig install because it's a bit faster. If yeah, because Conda install what you try is if there's something else need to be installed, like not pure Python or something like they will install those things as well automatically from Conda install, I think. So that's why it takes longer time for installation. But if your stuff is like don't need those dependency, like pip install is faster and doesn't, yeah. Yeah, it works. Like it depends on your installation basically. If you use MATLAB, for example, like different MATLAB version, like is saved into different version of mat file. And like for if you use scipy like loadmat and savemat command, uh I don't know which version it support up to. Like most likely it won't support like the latest version. So I just tried earlier. You see like there's a problem with the format. Like it cannot recognize the format in Python. Most likely because my Octave version is too new that it's saved to a version that like kind of SciPy cannot recognize. So then you can save to the earlier version as I show you. Like you can add like /v4 or something like that to save to the earlier version like this. I save into v4 yeah, I tried it. This works way, and we can look at the content here. Oh, okay. Wait. I'm not sure you want to use .m. It shouldn't make any changes if you change the extension. And I think .mat is the extension you're supposed to use. .m file is by default is recognized as a script file of MATLAB. It's basically the code. But the mat file, okay, by the way, I'm not sure you know the mat file, family of mat file. The MAT file is just storing data. And let make sure that I didn't, yeah, make sure that, okay, it's working, like it's working good, right? It's actually store and actually can be recovered. So maybe just like in summary, like if you want to add this /34, if doesn't work, if it works, then like you can just say forever you want. You can go to like SciPy or inside Python and try to loadmat. If you run into any error, then most likely it's just your basically your MATLAB or Octave is too new. Like saving into a mat file is like too new. The format is too new that Python cannot recognize. Then just save to an earlier version. Then it should work. Okay. So okay, that's all I want to talk about I/O. And last thing, maybe it's last or second to last. Yeah, it's good to, okay, it's like MATLAB is so easy to use because it have a nice help file, right? So in Python as well, like you can help anything. For example, I can help, let's see, I don't know if I can help pip. I cannot actually. Maybe I need to, yeah. So it gives you lots of explanation there. Or like you can help an object as well. For example, like I have mdic is a dictionary, right? I can help that variable mdic2 maybe, like, so it's a dictionary explain like what's the dictionary supposed to mean, and also like what kind of like function are there basically. Let's say do they have like for example, there's a size of function here. Oh, let's see. And there's a clear that remove all item. Let's say, and that to clear. So it should now clear the dictionary. And also like you, besides like help, you can also use dir. It's kind of like look for like what commands or like what methods are available inside the dictionary. So it's like the same thing as here, like, but it's just more concise. Like you look at like what kind of like commands are available here. And also like besides commands, also object as well. Like if it contains some objects, then as its members or like as its children, then it will be listed here as well. And there's also like a question mark command. I say, do I have maybe not? Yeah, let's see. I guess SciPy maybe like SciPy is I import that earlier, right? So I haven't import that. Maybe I import SciPy or import numpy, and then I can pull out like documentation like this in a different window here. And basically same thing, like same as help, I believe. It's just it is kind of like display a little bit nicer, I guess. And okay, and by the way, like we we look at a little bit numpy, right? Let's see, did we? Yeah, we look at a little bit numpy last time. So let's do some porting here. So let's do some simple porting. And maybe before that, like let's like play with like matrices a little bit. Like numpy is like a kind of numerical Python. Is like more like you can, as like in MATLAB, you can play with like higher dimension or higher order objects. Like for example, like matrices, tensors. And tensors is basically high dimensional arrays. For example, like the second order tensor is just a is matrix. It's just you have like two-dimensional array. And so for example, like I can create a all one matrices, like maybe like with dimension like 3 by 3. So I have these all matrices. And maybe I can do, by the way, this is multiplication. That's like this is stand for matrix multiplication. So for example, like maybe like I give you a simple question here. So what is 2 MP1s 2 2? So this is a question. Okay, question 2, I guess. So what? This is like kind of a review of linear algebra. I'm get used to the numpy kind of syntax as well. Yeah. Yeah, or if you're in front of the computer, you can try it out yourself also. Yeah. Right. Okay. I mean like wait. Um I for the last couple of times I'm pretty relaxed in the sense like whether you guys make absolutely correct answer. But I guess I will try to get a little bit stricter from now on. Like if your answer is not absolutely correct, you'll get half of the point. So make sure you write a answer is actually correct. So that's if you want to correct your answer, like you can type it the second time as well. Um, we'll just take the okay, but for you guys don't didn't realize that like the recordings is available, like it's on the website. So if you pull down to the website, like go to the table at the end, like the calendar, like with the video is basically there's a link like for each of the day there. Yeah, so you should be able to find the video there. Um yeah, so I guess I more or less get the idea. So it will be a matrix. Uh oops. I guess I have a typo here. Oh, by the way, you should ignore my typo. Assume the typo was not there. Yeah, so yeah, that's what we should get. And let's okay, let's really do some porting. Okay, let's erase this. So to do porting, I will kind of like load something called Matplotlib. So it's like something is very similar to MATLAB, the command. So therefore, I guess why the package is called Matplotlib. So I import like pyport as plt. That's a kind of like boilerplate kind of code that like most people will use. I say import that pyplot module from that package, and usually people will rename that as plt. I mean, Jupyter, like, there's some magic. Like, by the way, like Jupyter have a number of magics. I don't remember most of them. So the magic is just is is just restricted for the usage inside Jupyter. I think the most useful one is just this one, Matplotlib inline. So it will make sure that like what you plotting will be like plotting just inside rather than will pull up in an extra window, additional window. So and it can be simple. Let me just try something very simple. Like I can plot like, let's say, a line here, like from a line. Basically, I give a variable. It's like 0 to 9, right? So it's just a. So if I just give one variable, so then I mean, yeah, give one variable, then like by default, like the x-axis, this will be like just given the y values, right? Then the x values will be just like from 0 to the length of these variables here, or length minus 1 that variables here. So I mean, this is the same as doing this. Yeah, and I can maybe I want to plot have like the y values added by 2, let's say. So what's wrong here? Like if I do like this. Oh, I guess I don't this is not an official question because I think it's hard for you guys to type this. So, but just want to think a little bit, like reflect a little bit. I cannot do like this because this is a list command. If okay, basically this will give me an error. It's an error message because for list command, when you say add a list, you can only a list add another list. And also like if you add two lists, just concatenate them together. So here I don't actually want to add the list, so I should kind of convert this into a numpy array first, right? And maybe I convert to numpy array. Then the numpy array I can add that, like by default the add command for that one. Now is I have a vector add with a scalar that as I expected will shift the y values, so that now I have a value start from 2 instead of starting from 0. And you can look for example, like maybe I can do a sinusoidal here. Maybe my range value, my x, let's say x is a range. Let's see, like let's try this first. I'm not sure. 0 to 10 step 0.01. I don't quite remember. Is that no, it's not right. So that's the thing I'm not exactly sure. Oh, but of course I need to change both of them. So because otherwise the length won't match. Let's see, what do I get here? Oh, okay. I think this is probably the correct. Okay. I guess let me just try here first. Range 0.10, 0.2. Does it work? No. I guess I cannot. Okay. I cannot do. fractional values for that. So I cannot use range for fractional step basically. I think there's a linspace somewhere similar to, let's see, is that yeah, there's a command start stop and then like the number of also, yeah, I can have 0, 10 and then 100 of them. So then I have this is a vector. Actually this looks like a matrix, but it's actually a vector with 100 values from 0 to 10. And by the way, there's a shape command. This is a not exactly a command, a shape values. You can look at like what's the dimension of the object, the numpy object. So so instead of using range, I may use a linspace as a from 0 to 10. Maybe I have 100 values here, and let's just do this first. Yeah, it's just like before, but actually now I have 100 points here really. And I can maybe I make a sinusoidal of that. Like, so I want to plot the sine of that. Then I have a sine curve as I was expected. So this simple plotting you can Google more, like, or like you can just help, like if you have anything not certain. And just like MATLAB, I can like insert the labels, X labels and Y labels. I say I can have like X label is like maybe X here. So then I have an X here. Maybe I have a Y label, Y, and maybe add a title as well. New, let's say. And I can change the size of the figure. So for figure, that I should do that before plotting. So that determine the size of the figure, maybe 10, 10. So it get quite a bit bigger. So this is plotting. Let's see what else I want to show. Oh, okay. Here, the last command is a control the figure size here. So I first have this figure. This is similar to the figure in MATLAB, but the syntax is quite different. So inside you insert a figure size there. That's more different like kind of arguments you can put into this figure command, and actually you can just help that to see like what have that. Let's see. So I can change the figure size, that's DPI, face color, edge color, and so on and so forth. You can play around with that. Like, so yeah, okay. I guess that's more or less my Python introduction. Like for now, Python and NumPy introduction for now. We'll come back to that like when we talk about like go for some slides, I guess. So okay, let's get started quickly. I guess I hopefully we don't spend too much time on this. So and so okay, like maybe before I get started, like with what we mentioned, like we're going to talk about color and another overview, like what we cover in the topics. Like we'll talk about some low level stuff like image processing, edge detection, and so on and so forth. Camera colors, we will talk about color today. Color is basically also like some basic representation of image. So actually, at this time, you're supposed to know already, but it's just maybe a review. So an image, at least a grayscale image, is basically just a matrix. And we will talk about like geometry, so on. Like, we probably won't talk about structure of motion. It's like more technical, like a lot more technical details. we talk about recognition and Markov random field. I'm not sure, like we'll see about that. Like so, and also like some recent topic maybe. So low level vision, like as I mentioned, like there's some filtering, edge detection. Like we'll talk about this definitely, and feature extraction. Um, image formation, we partially talk about it today. It's like not exactly anything really detailed. And geometry will go through that like later on, and also like recognition, like uh, looking for features, like and face detection and so on and so forth. And there's some recent topics also. So now let's get started like with what we like to talk about today, color. An image, like what's image? So we all know what's image. We oftentimes we think of like lateral images, but um we use
Dr.
like
Chang, can I have
yes,
a question?
yes,
So if you go back one slice,
yes. Oops.
so in the is I mean about the recognition.
Oh yeah, yes, this one.
Yeah, yes. So in the second on the right upper right image, there's a single instance recognition. So I just wondering, is that instance is just the what's the definition of the instance? Is it the same as just everyday language, or is there any specific definition?
Uh honestly, I'm not sure here.
Mhm,
These slides, yeah, I don't think this is a wait. Um, yeah, I was just say like I'm not sure actually the single instance here like right? I don't
mhm,
think it's like actually nowadays I because I'm not paying attention for this line I should correct make changes here. Um, because I discover terminology keep changing. So people nowadays I think more about single shot learning and stuff like that.
mhm,
For that I would okay for that usually refer to like you only see the object once and try to recognize that. But I don't think it's referring to that here.
mhm,
So um uh, yeah, actually like probably it's the same thing like single instance in the sense like same as single shot. Like I think like that's what he think of. But
mhm,
it's yeah, yeah. So what it means is like I just have like one photo of that object, then I'm
mhm,
trying to recognize that object there. So and uh and if you it is more if you have like let's say if you take this as a learning problem, for example, if I think of like recognizing a bicycle or recognizing a car, typically it's not single shot because you need the data set to have like multiple of these bicycle photos to recognize the bicycle. So that's the drawback of um, some of these deep learning approaches is that like you will need a lot of like data points to recognize the object. But however, if you use like for example this more classic approach, you may do like single shot learning in theory, but typically, like what you're trying to recognize is the object is quite, it's almost like exactly the same as like the original. For example, you have this toy car here. It's not going to change into like different car. For example, like if you're trying to recognize this toy car, but the toy car have a different model, then you are not able to recognize that. Yeah. So, but yeah, so this is like a single shot learning, but also like this is a little bit more restrictive. So did I make it clear?
So the difference between this single instance and the category recognitions is just category recognition is we just need one object like a car and bicycle. But in the single instance recognition, we just take it, the parts to separate it.
Actually,
I
it's
mean,
different. Actually, it's different here. It's exactly opposite. For single
uh-huh,
shot, like you only have one photo. Think of like I only have this photo as my. For example, I need to recognize this toy car here. I just give you
mhm,
one photo. Now you're going to recognize this. So this is one way showing how you're going to do that. It's like, okay, I just find the distinct feature inside this car here, or like this toy car here. Now, if I look for a new photo here, I just look for these distinct features. If it matches like maybe 9 or like maybe 7 out of 10 of these distinct features, I'll say I just find a match.
I see. I
Yeah.
see.
Yes. So, but we'll go into more detail for this one. So, okay. One thing I forgot, I probably should pull you guys chat windows like down here. Otherwise, I won't be able to see you guys ask questions. So images. So we just mentioned like usually we just think of lecture images, but there's many different kind of like images like for many different applications. Like useful in many different applications, like medical images, and also maybe like this infrared image here also as well. And grayscale image is basically just a matrix, right? It's very simple. Like I have a big matrix, and we always heard of pixel is just actually refer to it's the original. Yeah, usually I don't even remember the original. It's referring to picture element, but everyone just pixel, like say pixel, and 3 dimension we have voxel and so on. And if this is just another example. Like if I have this linear, like the image recognition, image processing people like to use this image, like have a long history, and each of these pixel is just like different values here, create a matrix. I mean, you think of that like why computation is difficult, because you are really playing with like extremely high dimensional space, right? We also mentioned it last time. So each of these pixel, let's say this image is 512 by 512, each of the value here is like 256 different values typically, and then you have like 256 to the power 512 times 512. It's really really big. So and for color image, then is you will have like instead of one matrix, you will have like multiple matrices. For example, like in this case, this image, you have like the RGB, the red, green, and blue component each corresponds to a matrix. And a little bit about like anatomy, like for our eyes. But before that, like this is just for fun. I'm not sure like anyone can recognize anything unusual about these 4 photos here. Okay, it's not exactly a question, but like just let you to kind of this is one picture, like and this is a it's actually one picture. So you can see the color is important to us. Like we rely on color a lot to, of course, like there's edges here, like we have the edges like give us illusion that like this is separate. But the color, I guess, I give also a major role that for us to segment this one image into 4 pieces here. So the eyes, I'm not biology, I'm not going into detail, but like this, everyone like we study biology can see this before, and we have this iris. I guess iris is here. Like it's like the control the aperture, like control the aperture size of how much light you're getting into that. You have the lens here. Actually, I shouldn't say the iris control that way, but we have the eyelid control that. But actually, it's still like control is a bit, right? You have the dilation of the. It's not exactly the iris, but yeah, it's okay. Like that. Uh, um, anyway, like we are not in the biology class, but the point is like we have the basically sensors at the back here. Um, and maybe I talk about a little bit like interesting things about the uh, uh, biology. The things I find interesting is like we have the clones and the work cells. they're quite a bit different. Like probably you learn a little bit like in biology class as well. Like cone cells will be responsible to like uh, color vision, so it can be sensitive with different color spectrum. And the wall cell is like basically sensitive like to all spectrum, so therefore it's like grayscale vision. And it's also more sensitive as well. So therefore, like if when you are in a dim environment, when you are in the dark, like you cannot see color because like only your wall cells is working, and the cone cells are not working basically. And also some interesting fact here is like you have the basically you have the you know, okay, this is the eyeball here, right? The optical nerve here, like getting out of the eye into the brain here, that's basically no cells here, no warts or like cone cells here. Therefore, you cannot detect any lights here. So therefore, that's the blind spot here. And also like in the middle, uh, white in the middle of the retina here is the fovea that actually have the highest amount of cone cells here, high population of cone cells, but has almost no wall cells. Actually, that's a interesting question. I also like uh, you may try to think of like also like I'm not sure like you have this experience if you see the light sky in the at night. I just see the light sky, and you if you just like try to uh you will see more stars like basically off center. You if you go more center, you don't see any stars there, or like you see basically much fewer stars there. Um, and the reason is very simple, right? Because like the wall cells are basically not in the middle. So and wall cells only wall cells can like be sensitive for in the dark environment. So therefore, you basically cannot see those stars at the center. And so this is just another slide. Okay, let me skip quickly all these stuffs. And and by the way, so we have three different kinds of the cone cells. That's why like we have this R, G, and B. We can recognize people consider this like the three kind of basic colors, like the red, green, and green, are like fundamental colors. Um, that correspond to the S cells. I have the let's see lowest wavelength, and the M cell is in the middle, and the L cell is I have the highest wavelength. So then, so therefore, this L cells, like cone cells, is more responsible to the reddish one. But by the way, this bandwidth is still like quite near the green one. So basically, both L and M is kind of sensitive to green light. So we have lots of cells are actually quite sensitive to green light. And and by the way, like we have three kind of cells. So and in practice, when what we see is I basically see a spectrum, right? So for example, we see if from a laser light, then will be like just have like one frequency here, like this one here. But if we have like different light source, for example, a light bulb, different typically have a spectrum of the light wave. For example, normal daylight is like that, and so on. And know that like, oh, okay, I didn't have that slide here. Let's see, do I have? Oh, I already removed that. So what we see a um see a color is basically is like a uh how the cells uh, are reacting to the light source here, or reacting to the spectrum here, right? For example, if I have like my cell here, like three kind of cells here, if I'm activating like my L cells here, most likely I will consider it's wet, right? If I'm only activating like the S cells here, then I will see in blue basically. And if I'm activating M cells here, I'll be seeing green. And actually something that is interesting, like for example, if I am activating both S and M, then I am kind of expecting like I'm probably seeing something like at this frequency, right? For example, like if I am at around this 470 frequency here, then I will activating both this S cell and M cells, right? So then what I'm expecting, I will see something like at this frequency will be something green, right? Now, if I'm around like at this frequency, like 5, maybe 550, then I'm activating like this M cells and L cells here. So then I will be expecting seeing something yellow here, right? So around yellow here. So by the way, like, okay, this probably like I will make it a question, but probably I need to be more difficult question. What do you see if I have something, a spectrum that activate S and L, but not M? What color do you think you will see? Maybe I should type the question here. So I have, yeah. My question is like, okay, if I have a spectrum that kind of like activate this S cell here and also L cell here, but it does not activate the M cell here. So do you know what color I will see? S and L, but not M. Oh, okay. For you guys who say purple, like I would just say like when you see like S and M, you will see purple, right? So more or less purple. Like this is a this is really blue here. I don't know. This spectrum is hard to say. I don't know. Maybe this is not a white color for the frequency, but yeah, this is actually I guess a very kind of tricky question if you don't know that already. But yeah, but this is you can probably like impress your parent about this. I mean, or like someone else, your friends, because uh, this is like knowledge is not very common. So um, one thing like for you guys to guess this green is actually a very good guess, right? But the problem is like, wait, I have the M cell is not activated, right? So definitely it's not green, right? If I see green, then it should be like M will be activated as well, right? So by the way, if all S, M, and L are activated, what do I see will be like white, right? So if this is all activated, I expect to see white, right? Now what I'm saying is like S and L are activated, but M is not activated. M is not activated. I already know it's not green, right? My brain will try to process the information and it will tell me, oh, by the way, M is not activated. It cannot be green because M is a most sensitive to green, right? It's not green. But it's something like but at the same time it activates the SML. So um um yeah, actually that's something like I guess probably no one can answer that. So it turns out it's a magenta. Uh, there's something interesting is that magenta is actually not a real. You can say it's not really a real color. For example, like in the sense that it doesn't. It's not there in nature. You cannot see it in nature. You cannot see it in rainbow because a rainbow has a uh, mono frequency, right? All this color here. Basically, it doesn't have like a frequency just saying, okay, this frequency at this frequency is magenta. It's not there. Magenta is something fake. We see magenta is like when our S cell and L cell are activated, but the M cell is not activated. We think it's not green, but at the same time, S and L is activated. We don't know how to process that. Then our brain will fake a color and we call it magenta. And by the way, I'm not even sure like everyone like see magenta the same color because yeah, so we learn color. Actually, you think of that is quite interesting. Like I see this color, most likely you guys see a different color because like, it depends on how your brain actually process that. But everyone will be like, okay, we see this thing, we call it magenta. But it's basically what happens is just like S and L is activated, but M is not activated. So maybe just go back to uh, a little bit more, earlier slides here. So of course, like the spectrum, like we sense that like will be relying on both the reflectance of the object is like reflecting and also the light source. For example, like under like a kind of white light here, like with the full spectrum. So we see like, for example, tomato is white, like banana is yellow and so on and so forth. Because like the tomato only reflecting the red lights and the banana or only reflecting yellow light. So like not exactly only yellow lights, it has a reflectance like this. So it reflects some green lights and reflects some red lights here. So therefore we see yellow. And this is like for blueberry. So it have a spectrum like that. Reflectance is reflecting like mostly blue light here. It does not reflect red light, so we see it kind of blue and so on. Um, and this okay, this is so therefore like just like for fun. Like, so therefore, if you're under monochromatic light, is single frequency light source, then like everything will be colorless like this. Uh, and a little bit more biology like SMML. Uh, when we mentioned what cells are absent in the fourth field area, actually S cones are also like uh, almost absent in the fourth field area as well. So therefore, like actually right in the middle, we are not sensitive to blue light. And as I mentioned, like both M and L are kind of sensitive to green. So we are kind of like quite sensitive to green, therefore. Um, and therefore, like when we design the cameras, we typically have like more green pixels than red and blue pixels. So just to reflect the biologies of our own. And a little bit more about biology, maybe just for fun, is like we have these different wall cells, like wall cell, okay. Also not different wall cells, different cone cells, okay. Uh, SML is the only cones. Uh, I'm not sure I understand your questions, but SML, first, SML may not be the only cones. That's something interesting. I just want to point out later. It's like some of you guys actually have more cones, like more types of cones than others. Right? But for most people, like we only have SMML. Uh, and walls and cones are basically like walls is sensitive to all color spectrum. So therefore, like you cannot use wall cells to distinguish color. So therefore, like when only wall cell is activated, we only see grayscale we only see black and white. So for example, like as I mentioned, like if under very dim environment, because cone cells are not sensitive to dim environment. It's not, you need quite a lot brighter environment to get it activated. So therefore, like we will be only seeing kind of like gray, black and white things, and only colorless when it's in the dark. I'm not sure I answered your question really. Yeah, because you can see with walls. You definitely can see with walls, but it's just you cannot see colors like with walls, basically. And yeah, this is something like I just okay. We mentioned like what cells I say lies in chromosome 8 and like S is a chromosome 7, L and N are chromosome X. You know, the chromosome X is basically the sex chromosome, right? Only, I mean, both boys and girls have that, but like only kind of like male have like the Y chromosomes, right? So therefore, like actually, because like guys only have like one X chromosomes, we have a higher chance of getting like color blindness of basically more clearly, more precisely, wet green color blindness than female than girls, because if we have one of these X chromosomes screw up, then basically we cannot kind of like recognize. Basically, we have like uh, LM like screw up and so on. So okay, anyway, that's another maybe like something like address your earlier question. Like is that like we only have like S, M, and L cones? Actually, for different species, especially birds, and many other mammals, I actually have like not mammals, actually animals, like for example bees, like have like more than 3 different kinds of cones. Like for example, it's tetrachromatic. They also have can see ultraviolet. Uh, and like some humans, they actually are a large proportion, is like a significant portion of humans, like actually like females, have 4 cones. But even have like some of you guys, probably like someone in the class have 4 cones, you probably cannot see really different color spectrums, like because this is like you require some kind of learning. Like probably you need to learn it like when you are a baby or like kids. Like someone need to you recognize you have like tetrachromatic and they train you precisely. So therefore, like and like very few people is able to see like tetrachromatic. For example, if you are tetrachromatic, well, you can see something like this. That's basically everyone is just seeing like the color is like this flower is like that. But if you're tetrachromatic, like you may see a different color like this. So I don't know. Right? So I don't know. It'll be fun. Like if you guys like any of you is tetrachromatic, let me know. Like you actually can see a different color spectrum from someone else. And okay, actually, I have this slide here. I should have like show it earlier. This is like mathematical, like basically we mentioned earlier that like what you see is really depend on like how S, L, and L cone cells like responds to a spectrum. So therefore, like these two different spectrums actually will be recognized as exactly the same color because just it have like same response from the cone cells. So and we mentioned earlier that magenta is a fake color, and this is some kind of fun. So now a little bit about cameras. So we pick 3 colors because we have 3 cone cells, right? And we have as I mentioned earlier, because we're more sensitive to green, we design our cameras to have more green pixels than the red and blue pixels here. Um, and a little bit about color space. Of course, the most natural one is the red, green, and blue color space, RGB color space. So we just split into red, green, and blue component. And if I have a color image, then like again, I will just have like split into 3 matrices, like for 3 components instead. Um, by the way, like if you use OpenCV and use the earlier version in OpenCV, they use a BGR color space, I think. Yeah, BGR, yeah, or GBR or BGR. So it's kind of historical reason, but I think the latest version, they changed it back to RGB that everyone use. But if you use the earlier version that you may, if you capture like signal or like capture video from the webcam using OpenCV and you want to display it or like save the image, you may need to like convert to like the RGB color space first. Otherwise, like your color will be quite weird. You will have like something red will appear to be. Yeah, it's actually it's not really that significant. It's it's just a format problem. Like for a long period of time, I don't know, just when they introduced OpenCV, BGR is kind of more popular for some kind of hardware reason. I don't know. Then they adopted that, but now it's like RGB is like dominating. So like they for the the latest version they change it back to RGB. So, but if you use an older version, you capture video. I mean, the your video doesn't look right in terms of the color. Then most likely is because of that. Then you want to convert it back, uh, the the colors. So and RGB is not very intuitive. Like so people introduce this HSV color space. Basically, you have like hue, value, and saturation. So hue is like what kind of color, like frequency, and then this saturation is like when it's not saturated, it's like more white it looks like. So if very saturated, it's more like into that frequency. And then value will be like the basically the brightness there, like what was the intensity of that pixel. Um and and by the way, like you can of course like uh the luminance will corresponds to people also kind of distinguish like wait, yeah, that's difference because I think of that if you use printer, I don't have a slice here, but if you use printer, you will have because I think of like what you see in the object here, you're basically reflecting back the light is like what you see, right? But in the printer, it's different. Like when you print something, it's going to whenever you print something, you're absorbing that color, right? So you have a very different color map in for printer. Basically, when you print a color, you're absorbing additional color there. So for example, like when you have uh, a toner that have like three different color elements. So you put more and more color elements there, you're going to absorb more and more colors. So then you are going to become more and more black. But on the other hand, if you think of like object or like the spectrum that we mentioned earlier, you have more and more color. Actually, you appear more and more white. So therefore, like for printer, it's exact opposite. But I don't have the slide here actually. Like yeah. So, but that's basically you just think of printer is like exact opposite. So by the way, like here like yeah, absorption instead of reflection. Yes. Yeah, that's two terminologies that people often mention is luminance and chrominance. Chrominance is correspond to colors, and luminance is just correspond to the intensity. So because I here I basically we split into if you think of the HSV value, the V value is correspond to the luminance. It's like how bright your pixel is, and HMV will be correspond to the color. So we can split color and split luminance and chrominance precisely using the HSV color space. Um, so actually, I only have 1 minute. So, but I will go quickly here, just end here, I guess. So I have like this, just an example. I have just showing like luminance and chrominance. In terms of vision, in terms of luminance, at least for us to understand our environment, luminance is much more important than chrominance. And besides HSV color space, we also have this YUV or YCL, CBCL color space that is actually an approximation of this HSV color space, but this color transform is linear, so therefore much easier to apply. And in practice, this YUV or YCLCB color space is often used in compression because we are less sensitive in the chrominance components. We may first convert a color image into YUV component, and then like for the U and V, the chrominance components, we just downsample that. So, and so in the sense that maybe the original pixels, I have like dimensions, I 100 by 100. Then I'll downsample the chrominance component into like 50 by 50 for U and V, and Y I'll keep like 100 and 100, and then can achieve higher compression. So there's other color space. I'm not going to talk about that. Okay, I guess I would just stop here. Like and maybe next time we'll first go for a little bit more OpenCV, just like shows kind of like video capture like using OpenCV. So I will end here unless you guys have any questions. So I will just wait for 5 minutes to see you guys have any questions. But like we'll just basically see you guys next. Yeah. Uh yes. Okay. Maybe I pull it again, I guess, because this question like has been asked several times. If you go to Canvas or like you see it linked to the course website, right, or my website, right? And if you go to course website here, there's the video is put it here basically. Yeah. Okay. So yes, I will be ending the yes. Okay. It's also on the course website actually. This are the slides here. You see here. This I didn't change it yet in the previous. I changed it real time basically. But for you can look ahead for slides here. This is the slides. But I probably will edit that like before the lecture. But I just copy it from last year basically. So yeah. And that's also like yeah wait a sec. Why is wait a sec. Oh yeah, this is all right. So that's also some code running that is shown here. I think does it work? Let's see. Oh yeah, it's okay. Yeah, this working. Yeah, you may even try it ahead now. I mean this is the code. I will go over that like next time as well. But this would work. Like if you want this thing like in Jupyter, like you save it into a Python file, um, it should capture a video stream from your camera. Yeah. Okay, sure. So I will see you guys on Thursday then. Yeah.
Thank you, Dr. Chang.
Sure. See you guys.
See you.